More than 400 years ago, Galileo first pointed a small telescope at the night sky, ushering in a new era for astronomy. Today we stand at the brink of a similar revolution. At the Vera C. Rubin Observatory, designed to function as a sky-scanning machine night after night, it will capture even the smallest motions in the universe. From quiet asteroids drifting through the heavens to stars that suddenly flare and fade, and even to hidden signals tied to the greatest mysteries of physics, dark matter, and dark energy. This telescope is named after astronomer Vera Cooper Rubin, who transformed the field with what seemed to be a simple question: why don't galaxies rotate the way we think they should? According to Newton's laws, stars on the outer edges of a galaxy should move more slowly than those near the center. But Rubin discovered that they move at the same speed, something impossible, unless some invisible form of matter is holding the galaxy together. That discovery provided the first strong observational evidence for the existence of dark matter. Now, the observatory that bears her name is set to continue that unfinished path. This is where a new horizon opens. This is a space for you. The Vera C. Rubin Observatory is officially embarking on a 10-year journey known as the Legacy Survey of Space and Time (LSST). The plan is to capture the entire southern sky repeatedly, every few nights for a decade. By layering, comparing, and analyzing these repeated observations, scientists hope to uncover every change, motion, and secret hidden in the darkness of the cosmos. What makes this mission possible? At the heart is the largest digital camera ever built for astronomy, roughly the size of a small car with a sensor area of 3.2 gigapixels. The system includes 189 ultra-sensitive sensors, each larger than those in most professional cameras, assembled into 21 modules called rafts. All are housed in a vacuum and cooled to 40-48 degrees to minimize electronic noise. At this temperature, the system can detect even the faintest streams of light from distant space. The camera's focal plane is over 60 centimeters in diameter, and each image it captures spans 3.5 degrees of the sky, enough to fit 7 full moons side by side. Each exposure takes only 15 seconds, and the image transfer to the processing system takes just 2 more seconds. So, what will Rubin search for? LSST pursues 4 key scientific goals. The first is to study dark matter and dark energy. By mapping the movement and distribution of billions of galaxies over time, Rubin will help scientists measure the universe's expansion rate and see whether it changes something that could reveal the true nature of dark energy, the mysterious force driving the universe's growth. The second goal is to observe the changing sky. Thanks to its rapid and continuous scanning capability, Rubin can detect events like supernovae, gamma-ray bursts, quasar shifts, and even the first signs of a newly formed black hole. Within about a minute of capturing an image, the system will compare it with previous data and flag any unusual occurrences. This is one of the fastest astronomical alert systems ever built. The third goal is planetary defense, protecting Earth. With its fast imaging and wide field of view, Rubin can detect thousands of asteroids every night, including objects near Earth. The fourth goal is to catalog the solar system. Rubin will expand our view beyond Neptune, reaching into the Kuiper Belt and possibly further. By discovering and studying these distant icy bodies, astronomers can better understand how the solar system formed and whether unknown objects remain at its distant edges. Rubin's first images have already demonstrated its immense potential. One composite photo made from 678 exposures over more than 7 hours revealed dazzling detail in 2 famous nebulae, the Trifid and Lagoon stellar nurseries, thousands of light-years from Earth. In another image, the Virgo cluster displayed over 2,000 galaxies in a single frame, resulting from more than 100 exposures. From a lone spiral galaxy, the view zooms out to reveal over 10 million galaxies. Another dataset showed 46 variable stars subtly pulsing, proof that our sky is always in motion. In the future, the observatory expects to identify around 100,000 such variable stars, possibly more than 1 million light-years away. And that's not all. In one 10-hour observation session, Rubin detected 2.14 previously unknown asteroids in the solar system, including 7 near-Earth objects. While none posed a threat, the key takeaway was the speed and efficiency with which Rubin identified them. Currently, all observatories on and off Earth together find about 20,000 asteroids per year. In contrast, during the first 2 years of LSST alone, Rubin is expected to discover millions of new asteroids. Every night, Rubin will track the sky, capturing every motion, sudden flash, or fading event, including those that defy our expectations. One example is Oumuamua, the first interstellar object to pass through the solar system. If anything like it enters Rubin's view, the observatory will detect it and issue real-time alerts. Over time, the Rubin Observatory will generate trillions of measurements from billions of stars, galaxies, and asteroids. Building such a massive data set could raise questions that humanity has never even thought to ask. Meanwhile, the James Webb Space Telescope, JWST, is also expanding our understanding, having recently uncovered several intriguing new asteroids. Using a new image analysis method, astronomers working with JWST have discovered a surprising number of small asteroids within the main asteroid belt. This finding could significantly alter current estimates of the likelihood of collisions between Earth and objects ranging in size from a house to a stadium. Although a stadium-sized object may seem large in the vastness of the solar system, it is like a grain of dust in a cosmic desert. In addition, the Webb telescope has been tracking a mysterious object, a comet-like asteroid located beyond Jupiter, with features never previously recorded. Archived data from JWST revealed the existence of a large and unexpected population of asteroids in the region between Mars and Jupiter, known as the asteroid belt. Less than a decade ago, an asteroid only a few dozen meters across exploded over a Russian city, releasing energy more than 30 times greater than the atomic bomb dropped on Hiroshima during World War II. The newly observed asteroids detected by JWST range in size from that of a bus to several stadiums. While much smaller than the asteroid believed to have wiped out the dinosaurs, they could still cause significant damage if they were to strike Earth. Smaller asteroids collide with Earth more than 10,000 times as often as larger ones. However, their small size makes them extremely difficult to detect early through existing surveys. A research team from the Massachusetts Institute of Technology (MIT) made this discovery by reanalyzing prior JWST observations of a star in the TRAPPIST system and happened to identify a hidden population of small asteroids within the belt. You might be wondering, do these newly discovered space rocks pose any threat to Earth? The answer is large main belt asteroids usually follow stable orbits between Mars and Jupiter. But smaller objects are more easily influenced by gravitational forces, making their orbits less stable and potentially sending them deeper into the inner solar system, increasing the risk of Earth impact. The discovery that the number of small objects in the main belt is at least 5 times higher than previously estimated may force scientists to revise collision frequency models. Webb is particularly effective at detecting asteroids because these objects emit more strongly in the infrared spectrum, a major advantage of JWST. The data gathered helps fill a crucial gap in the study of meteorite origins and the behavior of larger asteroids that could pose real threats to our planet. According to a recent study, scientists hope that upcoming JWST observations targeting around 15 to 20 distant stars over a total of more than 500 hours could help uncover thousands more small asteroids hidden within the solar system. This would greatly enhance humanity's planetary defense capabilities. What do you think about this? Don't hesitate to share your thoughts in the comments. Meanwhile, JWST has also turned its attention to another unusual object, a space rock located between Jupiter and Neptune. This is the Centaur planet named 2060 Chiron, a hybrid object with characteristics of both an asteroid and a comet. Chiron orbits the Sun approximately once every 50 years, following a long and slow path through the space between these two giant planets. The research team detected gases like carbon dioxide and methane in its outer layer, along with a cloud of dust and gas surrounding its nucleus. Most notably, this is the first time astronomers have found water ice and even light carbon-based molecules like ethane and propane on a Centaur planet. Study co-author Charles Shambo stated, "These results are unlike anything we've ever seen before. Detecting gas around such a distant object like Chiron is incredibly difficult, yet JWST has accomplished it. Scientists believe that objects like this have remained nearly unchanged since the early days of the solar system. Observing how they interact with their surroundings can offer deeper insight into the formative stages of the planetary system in which Earth resides. However, it's important to remember that Chiron, like all Centaur planets, is in a transitional state. Its final fate remains unknown and may be decided within the next million years. Chiron could be pulled inward by Jupiter's gravity, transforming into a Jupiter family comet with an orbital period of under 20 years. Or it might be flung back out into the distant Kuiper belt, the icy outer rim of the solar system where frozen relics dwell. The outcome remains uncertain, and true to its mythological namesake Chiron, the half-human, half-horse centaur. This celestial body dwells between two worlds, suspended between a past long gone and a destiny yet to unfold.